So I start this presentation by giving a quick photo tour of the house, followed by the site context and explaining the key design moves. I will then talk in detail about the main timber elements, namely the roof and the staircase, but I will also try to tackle other aspects as well, so you get a good overview of the entire building. So let's just start the quick tour. So this is the street context from a public car park in Northcote. The diagram on the left gives the initial idea of raising the land to form a green roof and filling the space below with the functions required. I'll go into that in a bit more detail shortly. So as part of the laneway language, the council during planning wanted us to maintain a 2-meter fence line. With the clever use of a sliding automatic gate, we can actually open up our entire house so it feels like the street does actually enter onto the plot. Now the house sits on a very narrow site, just 4.2 meters wide, which means internally there's no room for corridors. Otherwise you'll get very narrow rooms. So the whole house is split over 2 levels, and you enter via the staircase at the first floor. As you enter the house, you are greeted by a large open and lofty volume, flanked either side by exposed concrete walls, which support the timber roof floating above, and a timber balustrade, which follows the perimeter of the void, which brings light down to the ground floor. So just looking at the plan, so this is the first floor of the house. The veranda space at the front is deliberately very loose in its program as it acts as a deep threshold. The front door is a bifold door, so this whole space in east of the staircase can be used for chilling out zone. It's very good in the evenings because it's really protecting you from the sun. On the other side of the staircase, you have the kitchen island. It's a kitchen dining setup, very compact. And then you've got a door to the west, which takes you to the spiral staircase. So this is our compact kitchen, got everything you ever need. But what we've got to remember is that this house is in Northcote, and actually on the high street, you've got plenty of restaurants to go to. So cooking isn't an everyday occurrence here. So looking at the section, you can clearly see the 2-meter level difference across the site. So from the Frederick street side, the laneway side, you come in, and we deliberately sunken the house down so we're not exceeding height limits. But that's allowed us to locate the bedrooms on the ground floor, so they've got more privacy. They're protected by the noise. A few doors down, there is a public house, and it does get rowdy on the weekends. But luckily here, it's all very quiet. It helps with the solid concrete walls and obviously double glazing throughout. This is a view from the kitchen looking down into the snug. The snug is the heart of the house. So it's centrally positioned on the ground floor. It has this wood fireplace, which is perfect during those cold winter nights. And the flue extends all the way up past the first floor through the roof. And when the fireplace is lit, it it heats up the entire house. So here's looking at the plan of the ground floor. We used the circle as a primary spatial device to create the snug. and it is then mirrored to create 2 bedrooms either side. The in-between spaces are antechambers and vestibules, which contain the wardrobe, the bathroom, the utility space. Basically, we have removed any dark corridors and opened up as much space as possible in this design. So this is the rear courtyard, looking back at the west-facing bedroom. We've also got a herb garden here. We've got the stormwater tank, and this is the base of the spiral staircase that takes you all the way to the roof terrace. So the roof terrace is accessible. It's got a nice chill-out deck, but the majority of it is a brown roof, sort of a green roof, and you can already see there's 13 skylights that's bringing light all the way down to the ground floor of the house. And this is the view from the snug, looking up through the void at those skylights and the roof structure. So just in case you don't know Northcote that well, I'll just give a little bit more of the site context. Northcote is about 4 kilometers north of Melbourne CBD. The house sits at the rear of a shop unit where the land was used as a tandem car park. The area is well serviced by public transport. And Northcote, the high street itself, is a very active place to be. There's lots of restaurants, shops, pubs, etc. Always something new happening along the street. But at the rear of the street, the laneways can be sort of dark, dingy, often used for car parking, but usually just for keeping the bins. Now, Northcote, the surrounding area, there are large gathering hall-like spaces, churches, theatres, former factory lofts, which inspired the volume of the house. And located just 3 kilometers further north is the workshop of Power to Make. This is the manufacturing side of our business, and it's co-located with the architectural design studio, which we call LLDS. Here we operate robotics and CNC machinery for architectural research, and in this instance, to make building components for the house. We have a flatbed 3-axis router, which is the main machinery we use for most of our products, but we also have a robot cell with a cooker robot, complete with a turntable, and a lot of other sort of woodworking machinery, sort of the more conventional type. It's a relatively big workshop. It's about 500 square meters, but at the same time, we're a very small team. So we consist mainly of architects. Most of them were former students of mine when I used to teach at the Melbourne University. And then there's a cabinet maker as well in the mix. So this is our little team. Faces do keep changing over the years, but we like to sort of keep a happy place. So I'm now going to move on to our plywood roof beams. So that, in fact, is sort of the whole roof structure. So the roof is made from cross-laminated plywood panels. It's a design that we worked very closely with Rob Gnestick from TGA Engineers. In fact, we even published a paper on the techniques that we used and how to make a free-form roof. So this was presented at the IASS back in 2023. And if you want to know more, I'm sure this is still downloadable from their website. So this slide shows the whole process of the design, from the initial input through to evaluating the material choice and engineering, then detailing how the whole thing was to go together, and finally the fabrication and assembly. One of the main criteria is that the beams had to be made at our own CNC fabrication workshop. This was very much a cost thing that we realized if we could take on the fabrication of these beams, then, you know, we were more in control and we could take on the risk. So because our machines could only handle a 2.4 by 1.2 plywood sheet, we had to design the beams in such a way that they had joints in them. So each beam consisted of 3 layers of 18 mil thick birch plywood. And because the roof span is 4 meters from concrete wall to concrete wall, there had to be joint lines, staggered joint lines into nesting. So you can sort of see that coming into that play. Now, all of the roof beam components were fully modeled using Rhino and Grasshopper. So it became parametric. We found that this was the easiest and quickest way to do adjustments to the model as the design developed. So as we got feedback from the engineer who said, you know, you need to make them 300 mil deep in places, then we could just adjust the model. And then through the scripting, all the components that we had to CNC fabricated would naturally get adjusted on their nested sheets. And so it became a really efficient way, if there was that last minute change, to sort of just press a few buttons, regenerate the form, and we had new files to CNC mill. So the asymmetrical roof shape responds to overlooking from neighboring windows and maximizes daylight to the interior. Deep roof structure is used to block out the harsh summer sun. On the inside, we used 3 lines to define the parameter of the roof. The central volume responds to the snug location, so that's this line in pink, while the 2 straight lines at either end responds to a concrete beam on the west and the bifold doors on the east. On the right-hand side is the results from TGA engineers, the stress diagram. Their only real concern was when it got to the cantilever, because we wanted a really thin edge. So we sort of pushed them in order to get the beams to reduce to about 100 mil in depth. I think we ended up with 120 mil just because of this diagram. So for us to make the beams in our workshop, TGA insisted we had to do a test first to prove that it was going to work. So we made one beam first. It was actually beam 1 on the west-hand side, because it's the most simplest and shallowest to make. And we took it to TGA's workshop where they tested it. So it had been engineered to carry 3 tons or 30 kilonewtons. It actually failed at 65 kilonewtons. So having achieved that, TGA basically, Rob said to us, yep, go ahead, you can make all the beams. Another tricky detail for the roof was the deck, because this sits on the beams. And we sort of tested, because we wanted a birch ply soffit to go with the birch ply beams. So we tested a 12 mil sheet of ply to see how far we can actually bend it into a doubly curved surface. And then and if we could achieve it, then we could just easily screw fix it into the beams on site. However, what we found is that some of the doubly curved deck components, the ones highlighted in red, were just too doubly curved that you just couldn't bend. So we ended up pre-forming from just using 5mm thick material, these ones in red, and this is us sort of just positioning those preformed doubly curved panels into place. So as discussed, working with the standard sheet sizes to make beams and columns, and this is one of the front columns, required us to split the layers. For every beam or column, we had assembly diagrams to assist us with the glue up procedure. We had to make our own clamping bed, which we used steel box sections and M16 bolts. And so you could imagine, you know, each layer of ply had to be laminated together. So we're there spreading a structural polyurethane glue, which has a working time of about 30 minutes before it starts to cure. And because anyone knows that polyurethane glue sort of expands and foams up as it cures, and it's so important to clamp the two layers together to stop that from happening. So we're sort of running around, spreading glue, positioning the layer of the ply, and then quickly clamping it all down in place and running around with our tightening up bolts and things like that. Another aspect, just to throw this one in, is we had the ability, mainly because of our connection at the University of Melbourne, to actually do a point cloud scan of the space before the beams were installed. So here you're seeing that the concrete walls have already been cast, and we've got a point scanner, and we're locating exactly where those walls are, because although in our model it would be perfect for them to be like 4 meters or 3.9 meters apart, after the core we found that the wall was out, particularly at the west end, by about 20 mil. So as I discussed before, because we had a parametric model, we could adjust the model to where the concrete wall locations are, and then everything else just got updated automatically before the fabrication commenced. So here are those front 4 columns already. Luckily, we found this amazing crane driver who had this crane truck, so we could lift them on at our workshop, 10-minute drive to the site, and lift them into place. And let's just show you the overview. So here's the glue up sequence. So yet again, running around, the clean film was put on just to stop the glue foaming out of the joint lines and gluing the clamps together. And of course, it rains when you want to install anything that's timber. So all our timbered beams are protected here, but the railing plate was already installed onto the concrete, and basically the beams just dropped into place. And then the sort of the noggins, as it were, the perpendicular pieces that go between beams, they sort of very easy to install. And between the noggins and the beams, we're just using screws at diagonal angles. So everything is acting at one at the end of the day. And this is us putting those front columns in place. And here we are finishing off by adding the deck panels. Another feature of the roof is the skylights. So there's 13 in total. These were made from layering up the same 18mm thick plywood, and then they're inlaid with a sheet of brass internally. For this process, what you see on the left is us using augmented reality. So we're there with a HoloLens on. The model of the skylight is in there together with where the brass sheet is to be positioned. So that helped us locate it in its correct orientation before we screw fixed. The image on the right shows them being craned into position. And obviously, after the install, they're bringing a nice golden glow into the house. So there's 13 of them in total, and they were made in 2 halves for this on-site install. These are the bottom halves on the crane truck, and these are the bottoms with the brass already there being installed, being dropped into place. Basically, the rest of the roof was already being waterproofed with its membrane, and these were the last things to go into place. And after the roof, this is pictures showing it recently finished, where all the scoria is on and the vegetation is just starting to grow. And now, if you looked at the roof, it's almost completely green. And this is just another view of the light entering through those skylights. So I'm just going to finish off now and talk about the other plywood feature, which is the internal staircase. So the stair geometry, if we just look at plan, is bounded by the circle of the lower floor of the snug, and it actually turns into an ellipse when it gets to the opening on the first floor above. So the stair itself consisted of 237 layers of CNC milled birch plywood, with each layer being CNC milled and assembled on site. It's not just the stair, but it consists of a seat. It consists of the bookshelf wall, which faces the stair. So here we've got all of those layers drawn up. Now, the image on the right actually shows those vertical elements are actually threaded rods that basically, when we stack up the layers of ply, we're stacking up about a meter's worth, and we're stacking them over these threaded rods, and these are also staggered, but the whole idea is that we then tighten up the nuts on the threaded rods to clamp all the layers together. So we're not gluing the layers in this case. We're purely relying on these steel rods to sort of clamp the whole structure together, so it can act as a cantilevered staircase, and obviously the balustrade and wall as well. What you can also see here is, because we're using CNC technology, we can begin to sort of make rebates in the wall itself. So we've done rebates where the water pipes would go for the shower, which is on the other side of the snug, and also where we've put in lights. We've got electrical cables and holes and conduits all located within this wall. So we're avoiding sort of any surface mounted services at all. Now, several sheets of plywood were used in the making of the staircase. So yet again, we deliberately split up each individual layer to be as economical as we could be with the ply. We also, what you don't see here is we also inserted other little components which weren't actually part of the staircase into the making of this. And so you can see we've sort of added recess for our lights here. We've got our seat at the bottom and the whole thing, and you can sort of see where the joint lines were. So yet again, we're overlapping layers of plywood as we go up. And within this section, there would have been a threaded rod clamping all those layers together. And I probably finished a little bit early, but this is the actual bookshelf, and you can see conduits would have been in for use GPOs here. And I could start to answer some questions.
Wonderful. Thank you for that, David. That was very, very informative. I got a lot out of that, and I've got a bunch of questions to discuss with you. For the audience, there's almost 100 people here, bang on. If you have questions, please let me know, and we will get the most of our short time together. So the first question that has come through is from Jerry. He said, very for CLT. There wasn't any CLT in this project in particular, was there, David?
No, it's basically just using plywood layers. So that is our cross laminated timber in a way, because they go in different directions to each other. But then I suppose the main thing is you've got plywood that's a standard product that has all those veneers. Part of what we had to do in our workshop was then take those sheets and glue them together, just like the veneers themselves are glued together. So that was our big learning curve with the fabrication process here.
You took 3 layers of 18 mil thick sheets, is that?
Yeah, so each beam has a total thickness of 54 mil.
Jerry's question is still relevant though. He asked, how was approval obtained from the building surveyor, and did it incorporate a performance solution for the non-DTS elements?
Well, basically the engineer took on that aspect. They detailed everything. They approved the fabrication process. So, and as far as the building surveyor was concerned, that's all they needed. They just need an engineer to sign it off.
Wonderful. And with test results like you achieved, it's obviously a very, very robust solution, and that the roof, especially with roof beams being so deep, we often find that's a key constraint when we try and apply timber to many scenarios is how much roof depth have you got. If you have the depth, you can do a lot. Recently, a car park was constructed in Germany that was fully timber, and they had very, very, very deep, elements, and you've allowed that to express a beautiful fluidity through the roof. Is that, were you constricted by any key rules or stipulations, height, space, or usage, or anything that really got in your way or drove your choices?
Well, a lot of the drivers were based on what we could do at our own fabrication workshop. So that was a key one. In terms of the building design, it took a year through planning to actually get the approval, but their main concern was actually, you're losing car parking spaces. So it was a silly one, and that's why the house does actually have a car parking space, is because planners insisted on it, even though it hardly fits a car. No, I mean, in terms, we came across a lot of, when we're talking about constraints, one of the amusing things that we didn't realize at the time, which became a kind of constraint, is transporting some of the larger beams just on his 10-minute journey. You know, there's sort of rules that the highways say about overhead wires have to be a certain height. We kind of find in Northcote, they're not quite at the height they're supposed to be. And quite frequently along the driving those larger beams back, we were finding ourselves having to hoist over the NBN cables just to get us through. Luckily, the electrical cables are at the right height, but the NBN ones are just a little bit lower.
It sounds like you really lucked out with that crane installation in particular, because we all know how much craneage can dictate how a site comes together. It's amazing that you had that much reach. I've not seen a truck crane with that much reach before. It's good to know that they exist.
They do. I mean, he was a really sort of expert driver as well in terms of craning these into place. So yeah, he had a reach of about 15 meters, which the first three beams right at the western end, we actually had to put them in manually ourselves because the crane couldn't reach that far. But by the time you got to the heavier beams, which were like weighing about 300 kilos, then yeah, we needed that crane.
Got a question about the surface treatment of the plywood, internal versus external. What was used there and why?
Okay, so what the product we use is Osmo, so it's a natural timber wood oil. It's not your polyurethane or anything like that, because that's just too difficult to apply for your situation. So internally, it is an internal one, designed for internal furniture and things like that. While externally at the front, we did use their exterior grade, which we also use on the timber windows and everything else. So it will need sort of touching up every 5 years or so as it sort of ages.
And that will protect against UV and moisture damage. Yeah.
Yeah. It has. So it's very well protected. But then the beams themselves, or the external columns, because of the cantilever, they're pretty well protected from any rain anyway. So a little bit of water on them won't cause any issues. If they were just exposed for a long period to dampness and to UV, then yeah, I would be a little bit more concerned. But at the moment, they're performing really well.
Brilliant. Got a few questions about the roof membrane.
Mm-hmm.
How did you manage the risks of moisture exposure and damage during transportation and assembly of the laminated elements?
Well, there was a lot of tarp on site, that's for sure. We definitely wanted to keep the beams and the deck as dry as possible before we could get it watertight. So yeah, it's very much a lot of covering up and just hoping there's no leaks or anything like that. Luckily, we were during the summer period, there was a lot of dry days. So the build up, what I probably didn't explain is on top of the deck, then the insulation went on first, and then we used a liquid applied waterproof membrane, sort of a rubber bitumen based compound. So that just gets applied with a roller or painted on, and that's sort of got like, well, the product sort of says you only need 3 layers of it. We put about 7 or 8 layers on because we just wanted to be absolutely safe. And it's a nice product because it's self-healing. So if nails or screws went through it, it's supposed to self-heal. But having said that, that rubber layer sits underneath a fleece, then a root barrier, then sort of some egg crates and about 50 mil of scorio. So the UV light isn't getting to it. There's no way it's going to break down because there's no way we want a leak in this roof.
Absolutely. Thanks for explaining that. And the green roof, it looks like you'd picked desert perennials, very shallow-rooted plants on a sort of coarse rock substrate. Is that's probably the shallowest of all the green roof
it's
ideas, right?
Yeah, I mean, because there's two types of green roof. You either go for the intensive or the extensive. So the intensive would require sort of maybe 500 mil of soil depth, and then you can grow things like trees and that kind of stuff. Well, the extensive green roof can just be a medium that's like 25 to 50 mil at its minimum. What we've kind of gone for is a hybrid system where on top of the sort of drainage gravel that we've got, we then had basically these homemade pots that we've just used PET material to make a pot to hold the growing medium. And then we've planted sedum, mainly sedum. There's some grasses and other stuff as well up there, but it's mainly sedum, which can withstand sort of long periods of drought. And then when it rains again, it all comes back to life. Having said that, we have installed an irrigation system because we've got water from the stormwater tank that we collect. So every evening during the summer, we're given about 10 minutes of watering just to sort of keep it on the green side.
Brilliant. We discussed the concrete forms that line the walls of almost the whole structure. This definitely feels like a product of your workshop. Like there's no it definitely has a maker's mark, and everything from the complexity of the ridges and the way they undulate to the button that it looks like you've used to cover fixings. Can you explain how you developed that idea and then produce them?
I certainly can. So I think it started at the very beginning when we were looking into working with our first engineer and working up what the main walls were going to be built off. We wanted thermal mass internally. So this house doesn't have any air conditioning. So on a hot summer's day, it could be 40 degrees plus outside. The temperature inside rarely gets above 23, 24. You would have to have a sustained sort of 3 or 4 days of heat wave for your house to sort of then start to struggle. So we looked initially at block work to be the internal wall finish. And then we sort of went through a bit of value engineering and got concerned about site constraints and all of that. And we sort of realized it's just as cheap to do it in situ concrete. But the last thing we wanted was to just have 2 plain concrete walls flanking each side of the boundary line. So, of course, we did numerous tests in our workshop with numerous sort of different router bits in order to make a mold that we could put inside the formwork for the concrete to cast against. What we ended up with is just using one single V-groove cutter.
Quite a wide one by the looks of things.
Yeah, 150-degree inclusive angle. So, and all we did so we had sheets of foam, insulation foam, and all we did in the various things was control how deep the tool passed through the foam, and that created the sort of texture, the pleating, as we call it, on the walls, which you can obviously see behind me. And because it's in situ concrete, I'm just going to stand up and get one. You do have holes that are left in the wall where the said bars were. And then all we did was mill a little bit of brass metal, stuck it to a dowel, and that's what goes into those holes. So it sort of gives that cushion feel, that very soft feel. And it also, those buttons sort of act as hooks, and in other places we've got shelves that are supported from dowels that are inside those said bar holes. And I should also point out that, you know, milling all your insulation foam just to get that pattern, we were very conscious of construction waste with this project. So the vast majority of those insulation was reused as the insulation for the roof deck. So,
really?
You know, there's quite a bit of upcycling going on there.
How much repetition did you get across those forms, or is each concrete form wall more or less unique?
Well, we could only use it once. That was our problem with this technique, because it's not like a traditional form liner, which would be made of rubber, and that gets reused and reused. Because there were only 2 pours for the walls, so it was poured sort of ground floor just above the slab, and then the final pour above, because we had to use, because of site constraints, the formwork itself was a Peri Uno system, which is made out of plastic rather than a steel shuttering. So you could only go so tall in one go. And the nice thing about that system is it's quite small and modular, and each panel sort of weighs about 15 kilograms. So it was all man-handled in terms of its erection with no cranes. And yeah, it just worked. So unfortunately, every foam panel we milled was only used once, because the texture just varies throughout the whole wall.
Yeah, and you can see even behind you how it undulates with the plywood, but that's not a concern for waste if you're going to use the insulation anyway upstairs. That's brilliant. It's fantastic that you made. Like, it's always amazing when people are able to achieve soft upholstered results from a very hard material. And that's phenomenal. I just assumed that the formwork was timber and repeated. I had no idea that you went to that length to achieve that result. You must have done a lot of experimentation before you were comfortable, because that moment was a very unobserved result that would have affected the whole building at that point.
Yeah. I mean, we were lucky in the sense that we had the time and we had the facility to just test things out. So, I mean, the build itself actually took 5 years on site, mainly because of the way we were working. So if you can imagine, obviously the concrete walls were built first, and our workshop was busy milling the foam panels. And it wasn't until the concrete was completed and then we could come in and do a point cloud scan to see how accurate the walls were in the final positions, did we then start to mill the roof beams that went on top. So, and then, you have this time when you're on site installing all the beams, getting the deck on, and then we were waterproofing it. And because we were on site doing all that, I couldn't be in the workshop making the skylights. And that's why the skylights came in so late in the whole process. And as you could see from the slide, you know, where there was a skylight opening, there was tarp just covering those voids up until we could finish it all off.
How accurate was the scan compared to your expectations?
Pretty spot on. I mean, it was just one part of the wall where I think the off-form concreter sort of confessed that he knew part of his formwork shifted whilst the concrete was being poured. So the wall sort of varied about 25-30 mil from what it should have been. So
yeah, that's about
pretty,
what you would
pretty
expect.
good.
Yeah. I have a question here from Joe Spell. You mentioned that the timber staircase was cantilevered, so it only cantilevers from the ground level, and it's not supported by the walls around it. How did you support stair treads over the seats and bookshelves?
So that part of the staircase where the steps they are cantilevered from the wall, the curved wall, because the wall itself sits on the ground and then it sits underneath the first floor concrete slab. So it's pretty well secure. So as you can imagine, the steps themselves, because they're layered ply, they're sort of how to explain the process? So you've obviously got the, I mean, during you know, classical era, people would be making these sort of cantilevered staircases out of stone, and the whole idea is the internal riser would, you know, there'd be leaning on top of each other, and the forces all flow through. So it's the same principle.
There is a beam there.
Plywood.
It's just sort of disguised in the curve of the staircase itself.
Yeah, pretty much. So it's all the same principles. It's been done hundreds of years ago out of stone. We've just done it out of plywood, and it works. There's no bounce or anything.
I imagine it'd be solid as rock. I imagine that you would have felt a range of emotions assembling it, from excitement to tired
Exhaustion.
to exhaustion to were there any big moments where you got on site and thought, darn, like I just missed one little thing that could have saved me a heap of time, or were you going at a pace that sort of allowed you to perceive these challenges ahead of time and triple check everything the way that we'd all love to say that we do all the time?
Well, no, I mean, mistakes were done and mistakes were rectified as we went along. I think one of the advantages of doing it as an owner builder and doing it over a 5-year period is you're able to appreciate the space as it goes up before it's finished, and you kind of think, oh wow, that's an unusual area, and then you start redesigning. You'll start changing how you initially thought, like the kitchen island would look. You'll change the design of it so you get to appreciate more of the concrete walls. Even the snug area, the sort of upholstery that finally went in there, that was very much a decision that sort of came from the plywood itself, what complemented it. So yeah, I mean, basic mistakes were done, as every sort of house build would have it, but the nicest part, I think, is being able to take your time and make it more interesting. And my camera's gone.
That's a brilliant observation, and
Go back.
I feel like that's something that a lot of a lot of us wish we well, wish we could do. It's brilliant, and the result speaks for itself. Like, there's simply no shortcutting the ambition of this house. I got a question about the fixings between the main beams and the infill, or the noggin beams, that, as you referred to them. Are they simply screwed on diagonal, or is there a bolt fixing these in place?
So you're gonna have to, yeah, my camera's playing up on my
That's okay.
laptop, but so if I disappear, I'm still talking. That's okay. So what was detailed by the engineer is when the beams meet the noggins on both corners, we're basically screwing diagonal screws in. They're like almost 200 mil long screws.
Right.
And we had to be very careful how we screwed them in. We actually made little jigs to guide us at the right angle, because if we went sort of the wrong angle, the bolt would actually start the screw would actually start showing on the other side of the beam. So we didn't want that at all. So where all these screws were positioned, we had already sort of pre-drilled during the CNC process a little recess for them, and also then a rebate so we could plug them up. Just like you'd find plugs on plywood sheets, we actually made sort of lots of 4mm plugs so we could cover the screw heads after they're all fixed together. So basically, I think there must be about 1,000 plus screws in the.
A lot of careful work to plug and hide those screws.
Yeah, a lot of drill bits we went through.
Indeed. With your workshop, what tools are you looking at getting next? Are there any big tools that you wish you had that you're about to get?
I wish we had the space for it. What we always really did fancy was getting a thermoformer, so we could actually heat up sort of material, be it sort of solid surface material or acrylics or stuff like that, and then we'll make a mold and we'll sort of have a vacuum bed so we could sort of curve material. At the moment, we just don't have the space. Luckily, there's someone that's not too far away that has one from our workshop, so we're always having to outsource certain things which we can't do ourselves. We don't even have a laser cutter, which a lot of people find interesting. They sort of come to us thinking, oh, you could just laser cut that. And I said, have to tell them they have to go somewhere else for that.
Yeah, you guys deal with thicker, more rigid materials than laser cutters are good for, it seems.
Yeah.
I've been particularly interested by watching the progression of the pinch forming metal formers over the last few years, the sheet metal formers. Pretty interesting. You have a lot of departure in this design from a lot of motives that appear to drive a lot of Australian houses, from the subservient kitchen to the circulation spaces. How do you go about communicating those changes as benefits to clients?
Yes, that's a good question. So putting an architectural hat on there. So I think, from building this house and sort of opening it up to potential clients, it's something that we've done, and we've sort of won. Well, we've been appointed for several other jobs, particularly in the Northcote area, funnily enough, where people have walked past this house and they've seen it and they've experienced it inside, and yeah, it's a very different kind of way of living. There's no internal doors as such. We just have curtains between the snug and the bedroom areas. It's very much an open plan, and it's very much deals with the fact that it's such a narrow site. 4.2 meters, you can't have internal corridors. We've sort of relied on vertical circulation. It's kind of unusual to have a house like this with 3 staircases. So we've got the internal one, we've got the spiral one at the rear, and we've got that one flight at the front. So you just enter at the first floor level. But the feedback we get from potential clients, new clients, is they're just amazed about the finishes, the way that the design just works, because for a house that's like 80 square meters in total, it feels so much bigger. You get to experience, really large spaces that you wouldn't if you've got a sort of a flat in the CBD. They're usually 80 square meters, and it's just full of 2 bedrooms and a kitchen diner, and you see nothing. But yeah, we've sort of
sorry, please.
We've sort of done our best to sort of make clients rethink about how they can live.
I think this project definitely does that. It asks a lot of really, really important questions, both about how we're living and how we fabricate. Thank you so much for joining us today, David. We got a lot of great engagement from the audience. Just before I say goodbye, I will close out. So the next WoodSolutions webinar will be on Tuesday, April 1st. It'll be on the design of timber connections, and we'll be joined by Adam Jones, founder of CLT Toolbox. So please don't miss that if you're interested in the design of timber connections, which is a very important point of any timber building, especially mass timber. And of course, the Australian Timber Design Awards are now open for this year. So if you know any exceptional projects that use wood in any capacity, from bus stops to university buildings, office towers, or pieces of furniture, please let them know that the Australian Timber Design Awards this year are now open. Thank you very much for joining us, everybody, and we'll see you at the next webinar.